Okay guys, Assalamu alaikum. In today's experiment we will show you how we can connect the different components for Thevenin and Norton equivalent circuit, and later on we will discuss about the maximum power transfer. So the circuit you can see here is actually we have uh, 5 resistors here, okay, and we have a 2 voltage source, and we have seen similar circuit in the previous experiment, which was related to the superposition theorem. Okay, so I have made this circuit here. Okay, similar circuit, if you can see closely. Now if you can see that this 10 ohm 10 kilo ohm resistor on the left side, then we have 1k, we have 33k, and then we have 47k. I didn't put RL here because we have to measure the open circuit voltage, short circuit current. For that we will not need RL, but definitely for maximum power transfer we will need it. So later on I will just discuss that how we can put RL. Okay, so let me first calculate. The first step in the calculating of the Thevenin or the Norton is to basically calculate the resistor, equivalent resistor of this circuit. Okay, for that I have to remove these voltages and voltage source. Okay, and then to remove these voltages I have to put a short circuits here. Okay, so let me do this here in this circuit. It's a short. I put a wire here. Okay, and another wire here. Okay, now it's ready to measure the resistor of this circuit, the equivalent resistance looking from the terminal of this A and B. Okay, so this A and B terminals are these terminals A and B, because this is same A and B. Okay, so now let me okay, the ohm meter or the multimeter is ready. I'm not giving details because already these circuits has been built before, and you have given a lot of discussion about, we have done a lot of discussion about this. Okay, so this is the this is used for ground here, one terminal. The other terminal is actually connected to this point here, or should be here. Actually this is A. Okay, so let me check. Yeah, it's 6.7, which is the required. Fine. Now okay, this is the AB terminal. Okay, because the resistor here it is 10k, so if you see here 10k A and B. Fine. Okay, so now we measured the equivalent resistance. Let's move on and measure the short circuit current and the open circuit voltage. Okay, let me remove this thing from here, and let me now put the 2 voltage source. The one is the 10 ohm, which we need to put the positive terminal here, and the negative terminal should go here. Okay, and we have definitely have to remove the short circuit from here. Okay, the other power supply or the voltage source, the positive terminal should go to the other end here. Okay, and other end of 33k kilo ohms resistor, and because it's a ground, so this should be common for both of them. Okay, so now in this way, if you can see the circuit, I have 2 wires here. Okay, the positive, the negative, then the positive here and the negative here. Okay, so this way I have connected the 2 power supply of 10 ohms and 5 ohm. Let me turn it on. Okay, so let me adjust the first one to 10. Okay, the second one to 5, and on off. Switch should be pressed to supply the voltage. Now the circuit is activated, and since we need to measure the open circuit voltage between terminal A and B. Okay, so let me connect the terminals to measure the. Okay, so this is the positive of the multimeter should be connected to A, and then B should be connected to this terminal here. Okay, so now you can see that's been connected. So wires are a bit long, but you can see here. Okay, so now it's connected, and I want to measure voltage here, DC. Okay, so let me see. Okay, this is 7.7 is the correct value. Okay, so this is an open circuit voltage. Now for the short circuit current, in this circuit I don't need to change anything. I just have to keep my multimeter on the to measure the current. Okay, why? Because if you see the circuit here, if I want to measure short circuit current, I have to remove this resistor. It should be short and put an ammeter here. Okay, so one end of the ammeter should be connected to the positive A, the other should be connected to the negative B. Okay, so here if you see, the positive end here should be connected to the positive end of the ammeter here. Okay, and the negative end should be connected to the negative, which is the same, the common, and then we have to press the DC current to measure the current. Okay, so its correct value, it's like 1.1 milliampere. Okay, so I think that in this way we measure the short circuit current, open circuit voltage, and the equivalent resistors of any circuit. Okay, now the next step is to measure the different values of the voltage across the load resistor for the maximum transfer. Let me show you the table here. Okay, here. Okay, so it's in this table we have to vary RL between 2.5 to 10.5 with the step of 1 kilo ohms, and we have to measure VL. Once we measure VL, then we can find PL, V square by R, using the formula. And why we are doing this, we have to see where the maximum power will be dissipated. Okay, and we know that the maximum power will be dissipated when the load resistor will be equal to the Thevenin resistor. Okay, the Thevenin resistor value that we have calculated is 6.7 kilo ohm, so it will be something around this. Okay, but I am not going to calculate the power. I just will show you how we can calculate VL for various values of R. Okay, so for this, first, since we are measuring the voltage, so we have to put it here, and sorry, DC. Okay, fine. Now it's measuring the voltage, but we have to, since it was open circuit, there's no RL here, we have to put the RL here. Okay, but however the RL is a variable resistor, so but we cannot use these resistors because these resistors has fixed value. So for RL we have another thing, a box that is actually looks like this. Okay, and you can see a different here switches. Okay, and that corresponds to different values of the resistor. So in this way I can vary the value of resistor. If the switch is downward like this, it means that it is off. Okay, since all the switches are down, it means that there's no resistor. Okay, and these are the two terminals of the resistor which are connected with the values. Just see this. Okay, so we have two connection. So I will connect the positive one, I mean the red one, okay, to the one end, this one to the one end of the okay, here I should connect it here because this is same terminal, and the other end should be connected to the ground or the low end. Let me find some place here to do that. Okay, so now since the resistor is very small, okay, so we have to see which value we required. Okay, because it's almost zero. Okay, it's because every switch is on the lower side. Okay, so the first value in the table, if you see, is 2.5 kilo ohms. So let's go there and see how we can do that. If you see, we have to turn on the switches which correspond to this value. So but if you see here, we have 2k, and there's no 500k, sorry, 500 ohms. So or 2.5k is not directly there. Okay, so we have to press this one. Okay, now 2k ohms is it's this box is giving 2 kilo ohms. However, we have to add 500 ohms as well. For that, because there's no 500 ohms, so we can do 400 plus 100. So it's like adding whatever switch you just turn on, it will add to the resistor. So it's now like 2.5 kilo ohms. Okay, and the value shown here, because the one terminal of this, although this will not be that much clear, however we have a lot of wires, but if you see here, this goes to the one end here, which is A. The other one, the black one, goes to the P, and the resistor value goes here to A. The other one is on the P. So it's like RL. Okay. So now I have set this to 2.5 kilo ohms, and it's giving the reading for the 2.5 kilo ohms across the 2.5 kilo ohms. Once I have the voltage here, I can just write it, whatever the value VL is, and then we just calculate VL square by R. Okay. Similarly here, if I want 3.5, so I have to turn off, turn this on. So this becomes 3k plus 400 plus 100, which is 3.5. Similarly, if I have 4k, 4.5k, so 4.5, 400 and 100. Okay, then we have, if I want 5k, so I have sorry, 5.5k, which is basically 4k, 1k, 100 and 4. So this becomes 5.5k. Similarly for 6, so 4k plus 6k plus 400 plus 100 ohms. Okay, so I think that's it. Once you get these values here, you just plot it, and the plot should be like something like this. There will be peak around this value in these two values. Okay, because the Thevenin equivalent resistor is equal to 6.7 kilo ohms. So when the Thevenin equivalent resistor becomes equal to the RL, we get the maximum power transfer. So I hope that you liked the video, and let's give you a whole shot of that. Okay, so this is what the circuit will look like when you are doing the experiment in the lab. Okay, thanks a lot. If you have any question, then we can discuss in the class.